Hey, robotics guys, here we go. I got a couple things we're going to talk about today. We're going to talk about the kits. What parts do you have? What can you use? Why are they the same? What's different? Who's better? What's the best? All right. How does this compare to that? Well, that was bigger. Well, no, we see that. All right. We're going to start with the old guy, Tetrix. This is the old guy, all right? Tetrix is interesting. Tetrix originally, when we started this, 2010, 2011, we had 3 teams advance to state that year. Tetrix was all you could use. In fact, they actually had limits on specific nuts and bolts that you could use and what you couldn't. Tetrix has a specific piece that lets you interface with Legos, like Technic Legos, and you could build anything you want. And a lot of this was Lego based. In fact, the processor was a Lego brick. Tetrix goes all the way back. This aluminum, some of this around the shop may be that old. All right. This aluminum, Tetrix gets a lot of crap from all the other teams. Oh, you're still using Tetrix. Here's the thing. It's a great system. You can prototype really, really quickly with Tetrix. You can go super fast with this stuff, okay? Here you go. You have 8mm holes and 8mm spacings on center, all right? I'm sorry. This is a 32mm C channel. I'm sorry, 16mm bolt circles, 16mm on center, 8mm across, all right? That's this pattern right here. This pattern repeats. Here's just a flat bar of Tetrix. Here's flat bar. Here's some other pieces of Tetrix. That's just some angle. Good and bad about Tetrix. You can prototype super fast. Let me say that again. Tetrix, you don't have a lot of wheel options. Tetrix, the gears stink. All right, they're huge. You have 40, 80, and 120 teeth, and they're huge. They grind. They chatter. They don't work well together. But honestly, that's not really everybody hates about Tetrix. This one's actually pretty clean here. Everybody hates about Tetrix is that they use this shaft. It's a D shaft. So there's a flat spot on this bar. You use a set screw on here to attach everything. In fact, you can see in between there's a set screw attached. Those come loose. All the time they come loose in the middle of your match, and then your wheel just falls off the side. Not okay. The gear options are not that great in Tetrix. Plus, it's the old stuff. Everybody wants the new cool stuff. This works okay, but it's not that strong. It does flex quicker than the other aluminum from the other companies. It's a good system. Don't let anybody put it down. The other thing that's weird, everything's metric spacing, but they use number 6 32 pitch standard screws. So 632 screws an imperial. It's a standard screw with a metric spacing on here. They use number 25 chain. So the chain in that system is standard, but all the hole patterns are metric. And so there's some weird meshes there when that happens. Okay, let's move on. The new guy on the block. This is actually a brand new system. This is GoBuild. And you might think it looks like the other one with just a whole bunch of extra holes. It kind of is, okay? So you've got 4mm holes, bigger holes here, the individual holes, not the large ones for the bearings. It's 48mm U channel, 8mm grid. So these holes should be twice as often as these. But if one's 8mm and the other is 16mm, they line up. All right. You put these center holes on here and they line up in the pattern all the way up and down. The screws are bigger with GoBuild. It's new. GoBuild has nice fancy wheel options, bigger screws, less flex, stronger. The other thing, bearings. Oh, they've got nice bearings in here. Problem is they've got bearings and spacers and washers, and just to throw something together doesn't go as fast as this. Yes, this only uses bushings, and you need to support axles on multiple sides so things don't flex and bend, but you can fast build with this. You can prototype really quickly with this Tetrix. While we're at it, we're going to switch for a second. This is a Tornado motor made by Pittsco, same company that makes Tetrix. It is side mount. That's how you attach it to the Tetrix system. This is a GoBuild a yellow jacket. There's not really a side mount to it. You face mount it. You bolt it into something. And this shaft, D shaft, motor shaft comes through. All right. The other option, main kit, Rev. We don't have a lot of Rev parts. We have a handful. Got a couple wheels from a giveaway. We have a couple nice motors that are really nice because they're adjustable. You can change these gearboxes in and out. All right. Those are really nice. But the Rev system is actually not a channel system like this. There's no pre-punched holes. It's an extrusion system. Well, what's an extrusion system? Before I say that, we do use Rev because Rev deals with all of our electronics. There's the expansion hub and the control hub. All of this. So this spacing matters because it doesn't always match all of these. All right. We also have some 80/20. Okay. 80/20 is a generic name. I think ours is from Open Builds. No, I know ours is from Open Builds. 80/20 is this. It's extruded aluminum. All right. Same thing right here. You've got this profile at the end, and then you've got all sorts of attachments like this. I could just take this, slide this into, loosen that set screw, slide this into there, tighten that set screw, and now I suddenly have a frame that's very rigid, very strong. I could put one in on this other side. I could do all sorts of stuff with this. I could build, you could get 4 sticks of this, make a table real fast. Put 4 corners in there, bolt it all down, and done. This stuff is interesting, but you've got to cut everything to custom lengths. You've got to drill holes in everything for custom. It's very, very versatile, but it's very, very, it's not great for prototyping because you need all your measurements ahead of time. In fact, what this is really good for is carriages like this. All right, so you've got ball bearings, you've got rollers. So this now moves and tracks in and out along here. All right, I've only got 2 of these wheels attached, but it would track in and out along here. So if you use those wheels, they ride right along that beam in those notches. They don't fall out, doesn't flip around. All right, we're down to it. That's 80/20. Got one more company we need to talk about for major parts we do. Not the Servo. Servo comes from anywhere. That is actually these are old school. They're high technic brand, but they're bought through Pitsco. You can buy these anywhere. The cage out here that prevents you from snapping this servo head off. This cage is made by Actobotics. Technically, Actobotics and GoBuild have the same parent company. Here's the difference. Metric, standard. So all the measurements around here are standard. You're like, that looks like the same pattern. It looks like the same pattern as this, right? It looks like the same pattern as this, but it's not. But what we do have are adapter plates where one side fits these screws, one side fits these screws, and then it just bolts right there. And now you can attach this to this. And they make those adapters. Servo City sells these, but Actobotics, they have their entire kit too. More specialized parts, I don't want to say not as strong, not as robust. They're made smaller things when you think Actobotics. All right. The motors, this is a Tornado. All right. We also have here, let me get 4195 out. Underneath here, these aren't Tornado. These are Never Rest. These come from AndyMark. These are 60-to-1 Never Rest motors. So the gearbox brings them down 1/60th of the speed they were originally going to rotate. In fact, you can notice right here, this is an entire Tetrix robot. 4 quick walls, 2 plates across the middle. This was built very fast. You bolt those corners together, you got standoffs, 3D printed piece. Some old things that are hanging around. Modern robotics, this electronics, not legal anymore for the competition robots, great for training robots. Some other things, one of these wheels, hold on. One of these wheels, I know, I just shoved it back on the other day, is loose because the set screw fell off. And so I was going to show you how bad the set screws, there. So that set screw right there just came off of that shaft. And you can see here, all over this shaft, how many flat spots and dents and divots there are, where this set screw just eats up. This aluminum is not that strong. So there's a lot of stuff going on. Guys, those are the different kits. Those are the different parts. We need to keep all this separate. They interact with each other, but you need to know where each one comes from so you know what hardware to use with it and how they interact with each other. All right, that's a great video today. That's the stuff we've got in the shop.